Okay, I guess we will then start. First of all, welcome everyone to this new ATEME webinar called Enhancing the Quality of Experience for OTT using ATEME and Dolby. My name is David Jarbole. I'm in charge of business development for the APAC region, and I will be acting as a moderator today for this session. Once again, welcome. To talk about this subject today with me, I have two speakers. The first one is Jerry. Jerry is actually currently a senior staff solution engineer at Dolby. Dolby has a very obviously long experience in broadcast industry, and Jerry by himself has more than a decade of experience in this world. He's working closely with free-to-air broadcasters, pay TV, and OTT operators in the Southeast Asia region. As a senior staff solution engineers, though Jerry is responsible of enabling Dolby technology with proper deployment and implementation. Jerry, thank you very much for joining us today. Michael is our own VP of Innovation. He will be presenting just after Jerry. Michael is actually a PhD degree that he received in 2006 and joined ATEME in 2015, where he's acting now as a VP of Innovation. He's leading the standardization effort for ATEME in different projects and activities like ATSC, DVB, 3GPP, or MPEG, DATSHIF, UHG Forum as well. He's also managing a couple of R&D projects with the R&D team in France. Thank you, Michael, for joining today. A brief overview of the agenda of the day. We'll start with Jerry and the next-gen experience. Talking about Dolby Vision and Dolby Atmos. Jerry will describe a bit more the principles in details, and we'll talk about end-to-end workflow. As for Michael, he will talk about the next-gen video and audio by ATEME. He'll describe the basic principles as well, some example of workflow and actual deployments. We'll finish by a Q&A session where we can respond to any question that you guys may have. Last point before we start, there is a Q&A button where you can type any question that you may have, and we will respond to them at the end of the session. Jerry, I will hand the floor to you, and I will stop sharing my screen.
Thank you, David. Cool. Let me share my screen. Hello. David, can you hear me okay?
Yeah, we can hear you okay, and we can see your screen. That's perfect.
That's good. Thank you so much, David, for the introductions. And thank you so much for everyone for attending these webinar sessions to join us for a topic that for today. So for myself, I will do an introduction to Dolby Vision and Dolby Atmos. Right, so that is the next generation audio video experiences that offered by Dolby. So my name is Jerry. I'm based out of Singapore office from Dolby Laboratories. So if you see me for the first time, you are sharing. David, I don't seem to see the slide on my monitor.
We can see your slides. It's all good for us. If you, yeah, we can see the agenda.
Okay. Okay, because I do have a monitor set up at my side. I'm seeing that still our speakers to this slide. I'm not sure whether others seeing the same thing. Okay, so maybe that's my. Okay, I just go ahead then. Okay, so the agenda today I will break into 4 parts. So start with next generation video experiences. Then I'll focus on Dolby Vision. As some of you may already know, Dolby Vision is one of the HDR formats in the industry. So on top of Dolby Vision, there is a HDR10, there's a HLG, they're all HDR technologies in the market. Right, so I will introduce Dolby Vision, and I also will share the end-to-end workflow that for Dolby Vision, so that you got the understanding how does the signal flow that from the content productions to services and to playback devices. Because Dolby as a company, I think we're involved into all the different pieces to make sure that the content is created in the right formats, and that going through the services which is like a Netflix, Disney Plus kind of like equivalent services. And at the end, it hit the devices like LG, TCL kind of devices. So I think we are be part of the all different ecosystems. So I want to show you the end-to-end things, how to do it. Then the next topic will be next generation audio technology from Dolby. So I will introduce Dolby Atmos. I will not touch for much on the personalization stuff because we do have a solution, but we are focusing on Dolby Atmos, like object-based audio experiences for now, for this webinar. But if you're interested to know more for the object-based audio for personalizations, I think I'm happy to take another topic that in the future, or you can reach out to me directly if you have any topic like that. Then I also will share the end-to-end Dolby Atmos workflow, right, end of it. So let me go straight into the Dolby next generation video experiences. So when you look at next generation video experiences, right, if you focus on the standard efforts happening around the world right now, I think in the US, there's an ATSC 3.0 that just newly publishing the new standards that in the market. I think that was published maybe like 1 or 2 years back. And DVB also improve on the specifications, and in the next generation video experiences that are being discussed so far and being adopted in the standard, we will see that high resolutions. So you look at my slide, right? The extreme left-hand side, you see that is a higher resolutions. So that is one of the next generation video experiences that have been introduced into the digital video technology. And the second a pillar that in my slides, you can see that is a higher frame rate. So that also improvement that instead of we are using the 50 frames per second of technology, now we improve to 100 frames per second technology. So this is a high frame rate to improve the picture quality for the future. So likewise, if you are in the region, say in the 60 frames per second, the high frame rate will be 112. Frame per second. So there's an improvement. Then look at the extreme right-hand side. That is a better pixel. So that consists of two elements. That is a larger luminance range and greater color gamut. So that is HDR technologies that offer to the next generation video experiences. So I look at it. So in the nutshell, right, I think we can see that three things that at least three new features that introduced into the next generation video experiences. So high resolution, which is from SD to HD to UHD, which is 4K or 8K. So that's one. Then the second improvement was a high frame rate. So we call it the faster pixel, that you have more refresh rate for one second of video screens. So the other thing is a high HDR. So it's a better pixel, which is a combination of larger luminance range, which is a color, which is the intensity or brightness of a picture, then greater color gamut, which is more colorful pixel. So my topic today will focus more on the HDR, the better pixel, which is consists of color and intensity of the picture, right? So let's look at it. You look at our human eyes, right? You look at our human eyes can see the full color. I mean, if you just walk out, step out of the room or inside the room, whatever they see from your human eyes, you can see a great contrast of the brightness and the darkness of the scene. At the same time, I think you can see the full colors that our human eyes can see. Right, so that is a natural image delivered to our human eyes. But that is what we are seeing in the actual world. Then for the digital TV, what are trying to do? I think we are trying to bring that, the full experience that what our human eyes can see, to bring it into a television screen. So in the TV screen that we want to see that. But my question is, are we seeing that using the current technology? So the answer is no. If you are using SDR technology, which is the standard dynamic range technology, which meaning that you are not increasing the luminance and the colors. I think what you're seeing in the current HD TV right now, you are having a lot of loss of the color information and the brightness of the pictures that you see from your human eyes, but is not able to reproject into the screens at your home, at the TV. Right, so this is, we are doing the HD TV, or rather the standard dynamic range TV that we have at home right now is actually based on the obsolete CRT technology. So that is what it is right now. That's why the HDR become a very important element to improve the viewing experience, that to move away from CRT to HDR experiences. Right, so you look at this picture from the capture side. As long as when you capture, the camera need to set to the raw video format, so that you preserve the picture quality to the maximum. Then to the processors, to the post-production and mastering, that potentially the current facilities can preserve the quality, but the big problem was the CRT technologies at the display. So that is a problem, that you are losing up the colors and intensities that the pictures that could potentially bring with some technology and not with the standard dynamic TV. So that is an improvement that needed for the next generation video experiences. So you see the improvement here. So we extend the image quality to a higher dynamic range, right? So you can see that from the post-productions, you can start to preserve. So if you are some from the studio sites and do content productions, and you create the content and you're preserving the content using Dolby Vision format, which is one of the HDR formats, then from that format, you can deliver it to the TV right now. For the TV that support HDR TV and support Dolby Vision, then you will get a better color and better contrast, because now the technologies that is currently available, and there is tons of services that has been available in the market right now, like you can name it, like Netflix, Disney Plus, and others, Apple, and many more services going to come out with Dolby Vision for the HDR elements. So it's capable of doing that right now. So I also would like to share with you what is color volume. So that would give you some kind of understanding what is CRT technology and what is the HDR technology. So you need to know the differences and what have been changing since then until now. So you look at the right hand side, that there's a human vision space, right? This is a color space that what our human eyes can see, the full color spectrum. So you look at one of the technologies were being standardized in the past, which is like past 30, 40 years ago. When you start the color TV, we use Rec 709. And Rec 709 only come up with a triangle in this size, and that gives you the color space. And from this color space is what you are getting your current SDR TV or your current standard dynamic range TV that from the HD TV, or even 4K TV panel. If the 4K TV panel is not HDR capable, then likely you are getting this Rec 709 color space. So you are still getting the very small color space there in the TV. Right, so with the improvement of Rec 2020, which has been specified into her APS-C and her DVB standards, so her Rec 2020 cover a wider color space that allows you to see a bigger space of colors that into the TV that's supporting HDR. Right, so this is a new color space. And with the color space, and you put the intensity of the brightness of the picture, like from this diagram at the left-hand side, you can see that there is an intensity at the y-axis. You can see that 1, 10, 100,000, and 10,000. This is an indication of the nits level. So nits is a measurement of the brightness level we have been using for current TV, right? So what we have right now for SDR, standard dynamic range TV, all the TV are typically in the brightness of 100 nits. So with the 100 nits and the 709 color space, this is the color volumes that you are getting. So that is very limited colors that you can reproduce into your TV panel. Then with a Dolby Vision or other HDR technology, then the intensity is getting bigger and the color volume also increased largely, and that will allows you to have more colors into your TV and make the TV screen and the video is more closer to our human eyes can see. So for Dolby Vision, we can, the technologies allows up to 10,000 nits of colors. And some other HDR technology allow up to 1,000, but Dolby Vision allows you up to 10,000 from the technology perspective. So let me share with you what's a typical end-to-end workflow. So again, workflow is very standard, very similar to what we are doing right now. So it's no change, productions, then distribution of services, then at the end, that is a playback devices, which is the apps that into the TV or into a set-top boxes or into a mobile phone or into devices or even Blu-ray players, right? So from here, what are the changes to adapt the enablement of Dolby Vision into service? So from the workflow that we have been introducing into the market and has been widely adopted, that's why you're seeing a lot of services like Netflix, Disney Plus, and Apple and others launching with Dolby Vision because they are adapting that kind of workflow that into their productions. So the key changes here, first thing, is the production set from the post-production facilities. So when you do color grading, you grade with Dolby Vision as a reference. So when you grade into that Dolby Vision reference, you are maximize the color space that you can get from Dolby Vision, and you also can maximize the luminance or the intensity of the brightness of the technology can take. So with the color grading solutions that you adapt with Dolby Vision, then you can grade your movie series or even documentary or whatever materials with the formats. Then you preserve a different color space and different intensity brightness set into the picture. That allows you to enable Dolby Vision. So end of the color grading process, what you get as a product is creating additional information called Dolby Vision metadata. So this Dolby Vision metadata usually is come up with the form of XML. So on top of the mezzanine video file that you are getting as an output of your productions, you have another file. It's a Dolby Vision metadata file in XML format that will be tagging along in the delivery to the next step, which is go to the distribution or the encoding. So the encoder will take the mezzanine file with the Dolby Vision metadata file together, and it will do the processing and to make sure that the composer of the Dolby Vision metadata will be composed into the video file before the encoding process. So that is the process that needed to make sure that is being processed correctly. Then after that, the Dolby Vision metadata will be tagging along for the services to the delivery, and at the end, at the playback devices, which is hitting on the TV, and the TV that's supporting Dolby Vision, for example, like LG TV, TCL TV, or any TV I can name it that support Dolby Vision, that the TV will be able to understand the Dolby Vision metadata and do the color mapping, to map the colors and the brightness of the scene based on the information that come from the source. That is how you get the full experience. So the changes for the end-to-end workflow, right, is starting from color grading to ensure that you grade your content productions based on Dolby Vision formats. And you go to encoding, and you need to make sure that you pick the encoder that's supporting Dolby Vision. I think that is a solution that you can see it right now, which is ATEME, that we are working together closely. ATEME has a solution to support Dolby Vision for encoding and distributions. So that is why we have a joint seminars together. Then hopefully that you guys will start to explore the solution from Dolby Technologies with ATEME solutions. Right, so what is Dolby Vision metadata? So the Dolby Vision metadata is to stir the display management. So that is the information that the TV or the display panel will understand. If the TV panel support Dolby Vision, it will understand that the information to them, then the TV will just based on that information and do the color mapping based out of the information set from the source. That to give you the HDR Dolby Vision experience. So it could be, so for Dolby Vision, one of the key features, right? Dolby Vision HDR is different than other HDR technology, is we are adapting dynamic metadata informations. So we are mapping the picture based on every scene. So different scene will have different set of metadata, because as you know, for one single movie, there's a lot of scenes that come from the whole movie, like for 1 hour. It can be a scenes that are very dark, and there are some scenes that are very bright. But that is all the artistic intent, that the directors have wanted the colors to be very dark to sort of like to tell a story, right? So every scene is a different brightness and different darkness and different color as well. So with Dolby Vision, we can map the picture quality based on every scene. Unlike other HDR technology, there may have like one set of metadata for all for the whole movie. So you are not be able to tell the story as close as to the director's intent. So that is the things that Dolby Vision is different than other HDR technology, right? So yeah, so that is a few of the key elements that from Dolby Vision metadata is to tag along with the service and go to the devices and will be decoded and mapped into the devices. So let's look at in the signal flow that for Dolby Vision metadata, you need to pre-process before go to the encoding. So so ATEME and the encoder to encode the video into HEVC, and with Dolby Vision, then it will be pre-processed before it go to this. And Dolby Vision, the whole idea is to check along with the video signal, and when it go to the decoder, the Dolby Vision metadata will be restructured back to the signal level, and that will pass it down to the display device, which is the TV. Right, so show the next screen. So the Dolby Vision metadata will go to the display panel, the TV will understand what is the information set from the source, and that will how the color mappings are happening in the device, if the device is supporting Dolby Vision. Right, so that is how the end-to-end Dolby Vision workflows are being done. Then here I also like to share with you Dolby Vision profiles. So there is multiple different profiles that are being used in the market right now, but ones that are being widely adopted so far, the ones I think 100% of the TV that's supporting Dolby Vision is supporting Dolby Vision Profile 5. So even Apple devices are all supporting Profile 5. So Profile 5 is for the video codec is HEVC, 10 bits. And it's a single layers technology. It's widely used by the OTT service and Netflix, Vudu, and Rakuten, iTunes, and others. So this is the Vision profiles that are being used. So the other profile I want to introduce to you is Profile 8. So Profile 8 is slightly different than Profile 5, because Profile 5 is one single layer solutions, but Profile 8 is a backward compatible. It's one single profile, but it carries two different HDR technology, or maybe one SDR plus Dolby Vision technology, right? So so for profile 8.1 from here, you can see that 8.1 is supporting HDR10. So it supports HDR10. Likewise, it also supports Dolby Vision, right? So if you want to deliver one single video stream supporting two different HDR formats, then you can consider to pick profile 8.1, which is HDR10 and Dolby Vision into one single signal. Likewise, you also can consider profile 8.4, which is a one single video stream carry two different HDR technology, HLG and Dolby Vision. So my understanding is that ATEME has a solution that's supporting profile 5, 8.1, and 8.4 already in the market. So it depends on the use cases in the services. Then you just pick and choose what makes sense to the service, right? So I think Mikhail will spend more time to talk a little bit on this. I think he will share with you the workflow. So that's pretty much for the video elements from Dolby. So now I would like to go to the next topic, the next generation audio experiences from Dolby called Dolby Atmos. Right, so just now was video, now it's audio. So if any questions, feel free to tap into the Q&A chapter. I will take the questions after we presented our topic. Yep. So for Dolby Atmos, this is a new approach to produce immersive sound. So in the past, we always produce audio in channel-based. We call 5.1 audio, stereo audio. But now the new approach called immersive audio in the object-based basis. So this picture tells you that this is a hybrid of our channel and the object-based audio together to deliver to you the immersive audio experience. Right. So this has been widely adopted as well. I think if you are subscribed to some services like Netflix, Apple, even Amazon, I think they do have movie titles that launch or enable with Dolby Vision and Dolby Atmos. So for Dolby Atmos, they are adapting this kind of like concept, object-based audio. So for this, so you can just in the imaginations that the individual animals here, right, in the center picture, are all being mastered into the object basis. So like an object-based audio. So when this parrots in the scenes, right, you are no longer saying that, okay, these parrots will be into the left channel or the right channel. We are no longer doing that. You're saying that this parrot is one of the object audio elements in the scene. So when the parrots are flying around in the scene, the audio will travel around the scene. So that will give you the whole immersive experience instead of you saying, oh, mix it to the left channel or right channel. You are no longer doing that. You mix it in the different kind of like methodology, different kind of thinking. You mix it into object-based, and that will deliver you the whole immersive experience. So for the home consumer setup, right, there is a differences in the setups as well. So if you look at 5.1 setup, that what we're having right now, you can see that it's very physical speaker channel basis. So the content production also have to mix the 5.1 and the playback side also have to play into 5.1 format. So all the speaker is fixed, left channel, right channel, center channel, LFE, then her left side, right channel. So this is fixed. Then when you move to object-based audio, you no longer limit by that. So the setup in here, just one example, you can see that there's 7 speakers in the x-axis and 1 subwoofer and 4 speakers at the top, right? So this 7.1.4. So this is a home setup. You can set up 7.1.4. You can set it up to 5.1.4. And you also can set it up to 1 single soundbar and with the speaker driver that tiering to even that's 2.1.1. It can be anything because when it's object-based, the decoder at the device will understand where does the audio goes to. It no longer limits saying that I have to be 5.1. It's no longer like that. It just depends on the physical speaker setup at the home, and the audio information will map based on the home setup and will just travel the sound based on the speakers that are being placed. So you no longer, and you are not required to set up like height speaker like this. I mean, this is just the illustrations to tell you, you can do it. But if you do not want to have a speakers at the ceiling, I think you can have a soundbar at the front or even have a up-firing speakers to beam out the experience. So that gives you the immersive audio experience. So Dolby Atmos is widely used in the cinema and now is in the living room and mobile devices. I think if you pay attention to some devices in the market, even Samsung has a mobile device. I think Samsung, majority of the mobile that's supporting Dolby Atmos right now. So you may question, oh, is this a stereo phone? How can you get Atmos? Because the content that comes in Dolby Atmos and the rendering process in the phone itself and the decoding will allows you to get you into the immersive experience. So it's not limited to cinema only for Dolby Atmos. It go to the living room and go to mobile devices as well. The whole idea is to give you the 3D space, immersive audio experience, and you move away from the channel base. So this is the differences at what Dolby Atmos object-based audio compared to channel-based 5.1 audio experience. So for the end-to-end workflow, right, I will not cover much for that workflow. I'll just show you the technologies that have been used for the Dolby Atmos. Right, so you look at the processes, again, it's a similar content production, which is similar to Dolby Vision, content production services, which is your Netflix, your Apple, and for the services, and the consumer devices, which is could be your Samsung soundbar, Samsung headphone, mobile phone, and could be LG TV with the Atmos, Dolby Atmos enabled TV. So this is all the end-to-end things that are happening. So we want to make sure that you get the content rights, then it delivered to the consumer and to deliver the full Dolby Atmos experience to your viewer, to your audience. Right, so for the content production side, because it's object-based audio and the audio elements will be a lot more information from the source. So you look at the source, this is just one example. That Dolby Atmos content at the raw format, mezzanine file formats, it could go all the way as high as 150 megabit per second. It's very, very big file because there's a lot of object elements. But once they go to encoding with the right tools and implementations, you will be able to encode it to a format that deliver the consumer at 448 kbps. This is for Dolby Digital Plus with Dolby Atmos enabled technology. But we also have a new technology called Dolby AC4. If Dolby AC4 to deliver Dolby Atmos, the bit rates that required will be way much lower than this. It's going to be 192 kbps, right? So so depends on what technology you pick and choose. So for the content creations, right? So just to show you the format, is a mezzanine file format, and it delivered to the services, and the services will deliver to the consumer devices in the different technology. So for mezzanine file format from the content creations, right? You likely will get Dolby Atmos into these three formats to begin with. I think that the technology is also evolving a bit. So for now, you could get DAMF. So that is a Dolby Atmos master file. So that is could be one of the formats that deliver to you in Dolby Atmos format. Then the other alternative to it, it could be ADM wave, which is we're seeing that Pro Tools and some of the content creation tools are supporting that right now. And likewise, it could be MXF IAB. So that's enough formats that support Dolby Atmos, right? So that could be the file formats that from the content creations. Then when it go to services, which is going to the encoding process, which is one example, Titan file, right? So there is a ATEME product that support Dolby Atmos encoding. It could produce you in the DD Plus JOC, or it could be produce you in AC4 into the delivery formats. Then that will reduce the bit rate to the delivery format like 192 kbps for AC4 and 448 for DD Plus technology. Then it will stream to HRS or Dash into the home consumer devices, and the home consumer devices that detected the Dolby technologies and will just render based on the information that come along, then they'll give you the immersive audio experience. So that is how the end-to-end things that being delivered for Dolby Atmos. So that is anything that you have questions, feel free to ask me after this. I guess that's pretty much I have for today. And yeah, so there's my contact, there's my email address. If you have anything, then feel free to talk to me, email me, or else I think I'll hand it back to David.
Thank you very much, Jerry. Very interesting
Thank you, David.
presentation. We'll let Michael share his screen. Maybe a quick question that we have in the Q&A chat. So just for all the attendees, you can type your question in the Q&A button. So feel free to ask any question. But just a quick one for the transition. How many objects can you handle in Dolby?
Very good questions. Yes, so we do have a limitations that how many objects we can handle. So from the technology right now, we support up to 128 objects audio to in the Pro Tools environment. So that is a maximum for now. Yes, 128.
Mm-hmm. Okay, thank you very much, Jerry. And then we'll hand the floor to Michael.
Thank you.
David, can you hear me?
Yes, we can hear you.
Okay. Thank you, Jerry, for your presentation. So I will try not to overlap too much with the presentation of Jerry that was already explaining a lot of things about HDR. So ATEME is doing a lot of things around next-gen video and next-gen audio because we really believe that this is the way to go to have the best immersivity in the end. So I will just explain what we are doing on the standardization side. Then I will explain some basic principles. and also some workflow that we are doing with Dolby and others, but mainly with Dolby, and some deployments or some trials that we have done so far. So ATEME is following many standards and many fora that we are contributing and following. So you must know that ATEME is doing his own encoders. So the two first, I would say, standardization body that we are following are the Alliance for Open Media, where we have the next-gen codec for AV codec for the web browsers, and they are looking at doing AV2. And we are also contributing to MPEG codec, so MPEG2, AVC, HEVC, and now VVC, and we did the first implementation for VVC with the first trial with SCS recently. Other than that, looking at audio, so MPEG is also doing audio codec, and we are also following what's going on at SIMT, DVB, and ATSC that are also contributing to the HDR and to the audio codec as per, and select which one they want to deliver. Another standardization body that we are following recently, that was 3GPP, that is also selecting HDR and also next-gen codec for their future deployments on 5G network. So he was explaining that quite well, Jerry, on his on the previous slide. So the human vision can look at several things, but the way we are doing that is that the brain is adapting to what he's looking at. So when you fix a point, then you can see what details in the dark area. And when you fix another point that will be in the white area, then your brain will adapt again, and you will see what more details in the white area. But you cannot do that with a TV. So you need to adapt the TV with something that is more static. And at first, it was SDR display that was only capable of doing 150 nits. And now we have more 300 nits for SDR display as is. And something that is quite interesting is that from the HDR camera, it's something that was already available since a while before HDR was starting to be deployed. So in 2013, just at the end of HEVC was not there with HDR at first. We were capable of capturing some content that we were able to grade afterwards with HDR. But all the details was already on the raw camera. So it was a Sony camera with a 16-stop capability of capturing the signal and the light. And we were capable of doing HDR afterwards with HDR10 and HLG on the same content. Today, HDR display are around 700 nits to 1,500 nits. There are displays that are less, but I would say that for HDR, that should be at least the minimum to have 700 nits at least. And you can see details in dark and white and bright area. And this can be really good when you are looking at a football match during the day. So just a quick overview. So we have OETF and EOTF. Previously, we got BT709, so that is used also for the color space. Here I'm using that for the transfer function. And at first, BT709 was only standardized at capture, not at the display. And they added a way to do that for the display later on, and not to let artistic content to the CE manufacturer to do so. So then they decided to have a BT1886, that is the standard for doing the reconstruction of BT709 on SDR TV. So it was done for HDTV mostly. Then we have ST2084, that is PQ, that is having a code value that is fixed, and you can reconstruct exactly the same picture on a display that will have 10,000 nits. And you have HLG that was standardized after, that is mostly used for broadcast, or at least people that are in the OB-WAN likes to use it. It's closer to what we have for BT709. And then people may prefer to deliver it over HDR, but in general, people that are in the OB-WAN are using the HLG transfer function. So people were thinking that that static metadata was not enough and cannot be enough for the display to reconstruct the peak value that we are having. So you can see that on some TVs, when you are using HDR10, you may have too bright area on some of some part of the display that you cannot see details into it because the TV is not adapting to this particular bright area. So then we got some adaptation techniques from Dolby Vision in 2094-10, from Technicolor that is called SLHDR in 2094-30, and from Samsung HDR10 Plus from 2094-40. And the idea is to be able to get some details in some bright or dark area that you cannot see with, that the TV cannot adapt without having this particular metadata. And then we got this particular slide from Yuri. So it's quite old, so maybe it has changed a bit. So Apple is moving to support HLG. At least this is what we are seeing we should see in a few. So people will support more and more HLG than it was. And we have also many devices that are supporting Dolby Vision, and probably many others that are in this list as of today. On the encoding side, same slide from Yuri. So ATEME is supporting all the technologies. Some only with Titan File at the moment, some only with Titan Live. But we are doing experiments with all of them, and we are supporting that with the different technology. For instance, Technicolor technology is deployed today by Sinclair on the ATSC 3.0 market, and we are doing Dolby Vision with Apple. So that's something also that we are doing today. So Titan can take any, so Titan family, I'm not speaking about file or live here, but the idea is to take any family. What we are doing today is that we are doing so we are taking a transfer function and we can convert it to another transfer function. So we can do PQ to HLG or HDR10 to HLG, HLG to HDR10, and we can also take 709 and do HDR10 or HLG. And we can do the opposite as well. That's a bit more complex, I would say. We can take also any color space as an input and do the conversion. So mostly in the file when it is P3, but we can do conversion as well from 709 to 2020. And we can take into account dynamic metadatas from Dolby, Philips, and Samsung. So today we are doing that with HEVC maintain. We are also doing that for the Blu-ray Association. And we are testing also with various devices today. We did the World Cup with Dolby for testing Dolby Vision Profile 8.1 and Profile 5. So for the HDR, we are also HDR10. We are also testing that with AV1. So that's something that is new. And AV1 is the first codec adopting HDR from the very beginning. So it will help deploying also HDR in the future. So something that I would like to emphasize is I would say the first big deployment that is using HDR and enhanced audio at the same time is ATSC 3.0. So they move from 1.0 to 3.0. 1.0 is MPEG-2. 3.0 is HEVC with HDR. So there is a big gap for the US market today. And there is no backward compatibility with 3.0 and 1.2. So that's not how DVB is working. In ATSC, they decided to move away from 1.2 to 3.2, and there is no backward compatibility at all in the broadcast on 1.2. And on top of HDR, they added also enhanced audio. So they selected two codecs in ATSC. So one has been selected for the Korean market, that is MPEG-H. And another one has been selected for the US market, that is SE4. So Jerry was mentioning that before. So today it's quite simple use case that they are trying to do is 2.2 and 5.1. But in the end, they want to have something that is more interactive than what they are doing as of today. And then they have interactive content and modernized grid. I don't want to speak too much on that part. So ATSC 3.0 is really a playground for immersivity. When I say immersivity, is having quality of experience that is better than before. So as I was saying, there is a big gap compared to what they were doing before, since they were using MPEG-2. Now we are moving to HDR, HEVC. We also added a scalable HEVC for Sinclair, and they are using SDR to HDR conversion with DSL HDR technology. So they use internet protocols, which is quite new. So they use Dash and MMT for delivering the signal. And they have the capability to do immersive audio, since they selected SE4 as their main technology for doing the broadcast of the audio. So what we can do with SE4 on our next generation audio on broadcast. So this is a slide from Fraunhofer, but we can do the same with Dolby. So you can select the prominence and also the position of the speaker if you prefer to have it. So that's something that you can do for the presets. So you can select. So an object can be a speaker, a commentator that you are having on top of on a football match or a tennis match. And you can increase or decrease the audio of this particular object. So you can have the music and effect that will be with higher volume than the speaker, or the opposite, because you would like to hear a bit more what the speaker is saying. Or sometimes you also want to remove it completely, so you can also remove the speaker from the music and effect and only have the music and effect. Then you have also the capability to have some, so 5.1 is more circle, I would say. It's not, the sound is not like if you are in a bubble. Atmos or 5.1.4 will bring you the fact that you can have some sounds that are coming from the top or from the bottom. So you will stay more in the center of a bubble. And then you have the capability to convert this particular signal, because if you have 5.1.4 plus one commentary, you may ask how you can deliver it to your 2D device, so to your headphones. How will it work? So you have some conversion from the renderer to be able to have the sound on the headset, on the headphones. So there is no incompatibility as of today with the fact that you start from a higher degree of number of channels and you convert it to headsets. And with the headsets, you will have the ability to have also this sound that is turning around. So if you turn your head, then you will have the capability to have also the sound that is turning around your brain. So I will explain some workflows. So we started quite early with HDR, so even earlier than that, but we did the Olympic Games with NBC Universal. So it was in Brazil, this one. So at this time, it was quite complex to do anything related to HDR. So we had to do some conversion between the Sony camera that was using the Sony standard S-Log3 and to convert it into PQ, because PQ or HLG or HDR10 or HLG are the only one that we can deliver to the TV manufacturer. So we had to convert it with 3D LUT. So it was an external equipment to Titan, and then we deliver it to the TV. And at this period of time, we were still facing a lot of issue with HDR10 because it was also new for the TV manufacturer. And the dialogue in between the set-top box and the TV manufacturer was just arriving. So it was HDMI 2.8. Then we did a lot of workflow with HLG 10. The idea was to have the so-called backward compatibility of HLG. That is a bit difficult to obtain. At least it was difficult to obtain at this period of time. We were missing what we have today is that we have a standard for doing the production in HDR10 or HLG. So we have good way to go from HLG to HDR10. So we did that. So Roland Garros is our playground for doing that. We were testing a lot of new technologies, and in 2016 and 2018, we tested HLG. We did also the World Cup with KPN, and we did some test match during the Euro 2016. So to come back to this particular webinar, we did also some Dolby Vision, some production live. So once again with Roland Garros 2017 and 2018. So we did the Roland Garros tournament by using Dolby Vision and Dolby Atmos live. At this period of time, everything was done beforehand. So Dolby Vision was a box before Titan, and they were sending ANC metadata to Titan and HDR10, or it was HDR10 here for the backward compatibility to the Titan, and then we were delivering it over different various broadcast systems, so DVT2 satellites, and also OTT. And we did the same demo with Tencent for a full basketball match in China. So something that we have done in 2018. So this one was really, coming back to one of the first slides of Jerry, we were combining various technologies and various, let's say, even now we are not using all of them at the same time. So it was really something that was new. It was pushed by France Television, BBC, EBU, IRT, and the idea was to test two things: HFR, high frame rate, but up to 100 FPS, and also to test the various NGA technology, so next generation audio technology that we have on the market. And at this period of time, we were using 3 of them. So the first one is MPEG-H 5.1.4 plus 4 dialogue. The second one was Dolby AC4 5.1.4 plus 4 dialogue. And the latest one was MPEG-H HOA. So you, in this particular technology, you are like in a bubble. And if you want to zoom in into this particular bubble, you can zoom into the sound as well. So if you zoom in into the video, then you will zoom in into the audio, and you can hear the parrots that Jerry was speaking about before. You can hear them far better because you go into details. You go into the direction of the parrot, and then you have also the sound of the parrot that will be higher. So that's something that you can do with HOA. On the other side, we use the first UHD 100 frame per second production that was done with a Sony Obi-Wan during this trial with EBU. We converted it into 1080p 100 FPS because we were believing it was enough for showcasing that higher frame rate would be good for the industry, and 1080p might be sufficient to showcase sports. So we put 3 different Titan in parallel for managing the different audio, and we were able to broadcast that during using an EBU satellite to various HDR display that was capable of handling NGA. So next one is the French Open tournament that we call as well Roland Garros. So in 2017, so you will see 2 similar diagrams, but I will explain them. So we were using in this particular 2017 tournament a captation that was done in PQ10 BT 2020 that we were encoding using HEVC MEN 10 plus Dolby Vision Profile 8.1. So we have the HDR10 backward compatibility. We were having DD plus JOC, so that's so we were using 2 codecs. One is DD plus JOC, and the other one is SE4. So DD plus JOC is the codec to encode Atmos with SE3 with DD plus, and we were also testing SE4 5.1.4.2 plus 2 dialogue during this particular event. So we broadcasted it to various displays using DVB-T2 modulation on the Eiffel Tower, so just in Paris. So I'm not explaining the one with 709, but on the other side, we were also doing some tests with some devices on site. So we were doing OTT delivery as well on site. I think it was more in 2018, but we were capable of demonstrating SE4 IMS, so the binauralization of SE4 on a device, and also the Vision during this particular event, 2018. In 2019, that's the latest one that we were doing since Roland Garros has been postponed to September, so we will do another one this year. This one was using SL-HDR for backward compatibility with HDR10 devices. Plus, we were testing this year, last year, sorry, MPEG-H. So it was 5.1.4 plus 1 dialogue. And we were capable of doing a lot of things with the UI of Android application on a TV or on NVIDIA Shield. So something new. So today we have Dolby Vision and Dolby Atmos integrated into Titan Live. So we can do profile 5. We can also do profile 8.1. And we have also integrated the profile 8.4. So we are doing there is 2 possibilities for some of the customers. Some of them will input HLG, and we can do the conversion into Titan to do profile 8.1. So they will have a HDR10 backward compatible workflow, or we can do profile 8.4, so take HLG as an input and keep HLG as a backward compatible signal, and then that's Dolby that is doing the up conversion to the TV for benefiting from the Dolby Vision metadata. And there is one more number here that I removed now because it's weird otherwise. So ST2094-10, that's something that has been standardized at DVB and ATSC 3.2. That's also something that we support in Titan Live. And for the containers, so we are using CMAF low latency for delivering the signal. So we can do HLS-LL with Dolby Vision, and traditional MPEG-2TS for delivering the signal. We have also integrated the DD plus JOC into the encoder up to 5.1.4. So that's something that we can do with the encoder. And we are doing right now some, so we are preparing the new Roland Garros. We hope that it will happen. And the idea will be to do AC4 this year in 5.1.4 plus 1 dialogue, and also to combine it with 2.2 or 5.1 signal. So when there is an advertisement, then we move to 2.2 or 5.1, and we can deliver it over CMAF low latency and MPEG-2TS. So there is a stream that is running. I hope it's still running, so it's still experimental. We are pushing in a low latency mode, and we are waiting for iOS 14 to support it from scratch. So the playback right now on iOS 13 won't be low latency, but we are pushing in a low latency mode. But for those that have iOS 14, it should work on QuickTime right now, and we are waiting for the new release of iOS 14 to be able to display it in low latency mode. So that's all.
Thank you, Miguel. Thank you very much. We are running slightly over time, so we can do a quick Q&A session. Share the screen rapidly. So if anyone has any question, feel free to ask the button for it on the top. I may have one for you, Jerry, if you are still here with me.
Yes, I'm still around, yes.
So one related to the AV1 actually, and we know that Netflix is going to use more and more AV1, and it's becoming more and more important. The question that I would have for you is, how do you foresee Dolby Vision in AV1?
Yeah, so I think it's just a matter of time, right? Because I think the market seems to see a lot of value for the HDR elements in Dolby Vision into the service. So we see Netflix like widely adopt with the content with Dolby Vision. Then there's Disney also coming up with that Dolby Vision technology in the service, and we foresee more and more operators with that. Of course, that is the whole reason that we have the whole team, that the Dolby team, and of course we partner with ATEME and others to support the industry. If there is a demand for services, then I think we're going to see more and more services can come up with Dolby Vision.
Okay, thank you very much. That's pretty much it. I'm not sure if anyone has any question. Feel free to ask. For information, this section will be or has been recorded and will be shared on ATEME YouTube channel. We'll pass it also to Dolby for them to put it in on their website. You have any question, feel free to ask. So Jerry, you got his email address. Otherwise, send a question to any ATEME representative. And we will be very happy to come back to you and give you more information. I think we'll close then for the session for today. Thank you very much, Jerry, for your presentation and details about Dolby Vision and Dolby Atmos. Thank you very much, Michael, as well for this presentation. And I wish you all a good day ahead, or a good night on your side, and talk to you very soon.
Thanks, David. Thank Michael and the ATEME team for having us.
Bye-bye.
Thank you, Jerry.
Thank you. Take care. Bye-bye.
Bye.